Right, so let's talk about the all possible four binary tree. So you're given the integer n, so you have to return a list of all possible binary tree, and it has to be four. So the left and right has to be what? It's either zero or two children, right? So this question is pretty straightforward. If you look at the output, right, it's going to be list of lists, right? So our function is going to return the list. So I think there is a function keep calling this all possible fbt. So we don't have to worry about the recursion, like backtracking. We have to remove the non-working node. So we just have to just write out a logic to say, okay, if this way is possible to generate a full binary tree, then you will definitely do the recursives, right? And then we don't have to worry about too much. So I'm going to talk about some constraint. So there's a constraint if n equal to 7. So imagine you have a root. So this will take over one node from the n, right? So when n equal to 7, I'm going to say, okay, this is what? This is my first node, right? So how many children you have? You have what? You have 6 children, right? So how do you actually need to do this? So you have left and right. This is 1 and 2. This is what? 3 and 4, right? This is what? 5 and 6, right? So in this way, when n equal to 7, you have 6 nodes for the children. This is doable. What happens if n equal to 6? When n equal to 6, how many children you have? This is what? This is 5, right? You have 5 children. So which one you want to delete to make the tree be the full binary tree? This is not allowed, right? So imagine you did this one, right? So this is not full full binary tree. So if you notice that if n is even, no matter what, you cannot generate a full binary tree. So this is the first tip, and also we are going to just keep decreasing our n, right? So if n equal to 7, right, we just have to decrease the number of the node for the left and right? So just for example, I'm going to generate this one, the top left tree first, right? We are going to pass in the one node on the left, and then rest of the node on the right. And then this is going to be what? How many nodes you have on the right side. This is going to be the total number of node minus your parent, one node, minus the number of accounts on your left subtree, right? So this is going to be the total number on the right side of the tree. So this is the count on the right, and this is count on the left, right? So there will be more than one node on the left, right? So you will definitely need to know that this is still going to be a logic on the right. And how do you know, like how do you increase your left? Let's be honest. If you say L++, right, when you're traversing using L++, we already know we cannot have what the even number when we create a subtree, right? So if you say n minus L, right? This is n minus 1, right? This is 6, right? And then we need one node on the left, and then the rest of the node is what? Is 5, right? So this is let me change the number. This is the 7. I mean the first node. This is the second node, and there's a 5 node on the right, right? So we already know that if there's one node on the left, how do you actually need to generate another node and make the right side of the counts possible? You have to say L plus equal to 2. For every single traversal, this is because when you say L plus plus, right, you will somehow make the right side of the tree even number, and this is not doable. And let me just stop recording, and you'll be able to follow along, okay? So I'm going to just write down the list of tree nodes. I'm going to say results. And you can do whatever you want. I'm going to say I want to declare the result on out of the function, but there will be okay. So I'm going to say if mod 2 is actually equal to what? Is actually equal to 0. This is not doable, right? So it will just return result. Alright, so if n is equal, if n is equal to 1, 1, when I'm decreasing the node, and then somehow when equal to 1, this is my base case, I'm going to add into the tree, I mean, so the list, sorry, and you definitely need to know, like, for every single node, value is actually equal to 0, right? And then when add it, I need to just return the result. So I need to traverse the children, so I'm going to say L equal to 1. So you have to know, you have a pair. So uh, so you have to starting from 1. If you don't have a pair, you can start it from 0, but you have a pair, right? So L less than equal to L minus 1, right? So L minus 1 represents 1. The minus 1 represents the pair. So you have to take L minus 1. And you have to start from 1 to L minus 1. This is because you want to ignore the parent. And also plus equal to 2. For every single time, you need to know, like, the count should be what? Two union traversal, right? And then when we know the left count, we already know the right count, right? So we say minus 1 minus the parent, right? Minus the the count of the left side. So this is right. So I'm going to say list of three nodes. I'm going to say left list, right? Equal to what? All possible for binary tree using recursion code, passing L, and I'm going to say R right list equal to all possible for R, right? So I will generate the possible for tree node on the left and all possible tree on the right. So if you notice, if you keep recursive code different, right, you'll definitely generate the first is a 4 binary tree right over here, right? So now we need to add every single node into the list of the tree, right? Because we haven't added. So if we want to add, we need to traverse tree node. I'm gonna say that in that list. Again, you can say tree node, right? And then we need to just create a tree node, passing the tree node 0, and then node.l, right? Definitely 0. I don't care whatever the left should be what? Left should be left, the right should be the right? Then after I generate this node, I'm going to just add it to my list, right? So you will definitely keep recursive code for this function and then generate every single node, and then later on you will just what? You will just have to return results, right? So this is going to be pretty much it. So let me run it, and hopefully I don't make a mistake. I do. So list of tree node array, sorry. And what else? Result with capital what? Capital N only. What else? Alright, so rest of the list tree node, right? And okay. So there's a problem. So I found out the problem. I shouldn't initialize my result also of a function. This is because I would probably like forgot there's a global variable on the also of the function. So I need to make it inside. This is my mistake. I was like thinking this should be not a problem. So if you run this again, and this will be possible. So for every single traversal, recursion, right? You need to know this. The list of the tree node result is really important. You cannot make it global. So when you submit, this is going to be global. So let's talk about time and space. So for the time, right? For every single node, you can either add or not add it, right? So there are two possible ways for a node, right? So how many nodes you have here? A node, nodes, right? And you have two ways, right? So it's going to be 2 to the n, right? For the time. And exactly, it's going to be the same idea for the space, because you don't know how many combination you have for the n. So 2 to the n for the time, 2 to the n for the space. So this one is going to be a vector search solution. So let's make this easier. So we can actually use the memorize solution. So if you want to traverse on the left, right? Traverse it on the left, and then sorry, if you want to traverse on the right, we passing one node on the left and the rest of the node on the right. So we already know the number for counts on the right. So if we want to use the same number for counts, then we can probably just quickly return the number, right? Where we don't have to traverse until the end, right? So let's make this to the tree map memorizing hash map. All right, memorization hash map. I'm going to say hash map. I'm passing integer. The integer represent the count on the current, right? And then I need to pass in the list of what? List of three nodes, sorry. And say map, and then it will be hash map, right? So this is my global variable. I can only use one side. So if I cannot find the map, right? If I cannot find the map, I mean, cannot find the value inside the map contains, see, I will come into the function, right? But I also have to double check what? The base case, right? I'm going to pass in to the base case. And what else? And if I can find it in the map, right? I will just say return map.get. And then we already know n should be what? Odd number, right? If n is even number, I'm going to just return the empty list of tree, right? So this will be the base case. Now we need to what? We need to traverse the left and right, right? This is not this is something we need to do it, right? Just do like this. And then after I traverse, right? After I traverse, I'm going to what? Sorry, give me 1 second to indent. So after I traverse the entire left and right, I need to put it into the map, right? So I will be able to know what's the current number of float right now, and then with how many children, right? So I will say put n comma result, right? So I want to making sure this has to be at the end after the two for loop, right? So this will give you the exact solution when you generate a subtree for the 4 binary tree. And let me delete this one. So yes, still doable, right? So I'm going to just quickly repeat again what I just said. So I'm create a hash map, memorize the number that I already traversed. And if I want to traverse it again, right? If you say the n equal to what? 5, I traverse 5 on the right side, but on the left side I still have 5 times, right? So I can just pull the number out, right? So if I don't have it, if I don't have the number in my tree map, sorry, hash map. All right, so it's hash map. Right? If I don't have a number in the hash map, right, I need to just keep traversing. And if I do, I will just return the correct number. And then the number is going to be what you have to return the list, right? So this is the list, right? Now you need to generate a list, and then you have to not making sure the n is the odd number. And if n equal to 1, you just basically generate a tree node and add into the list, and then you return the list right away. And this is why traversing the left and right child, right? And this is the solution. So let me submit. So this is the doable. So let's talk about time and space for the memorization. So again, this is what 2 to n for time, because you have to traverse the entire tree to see if this is possible or not, right? So it's 2 to n, and then space, I would say it's 2 to n, right? And this will be the solution, and it's quite long. So just making sure you enjoy the video and leave a like, subscribe, or comment, right? I will see you next time. Bye.